Welcome to Metrology lecture series. In the previous lectures, we discussed the measurement of major diameter, minor diameter, and the effective diameter of screw thread. In the present video, we will discuss the measurement of pitch of the screw thread by using the pitch measuring machine. Before that, we will discuss the effect of pitch errors. We know that pitch error is error in the spacing of threads, and cumulative pitch error means the total error in spacing of threads over a certain length. So let's see in the picture. Here capital L is the length of the thread and small e is the cumulative pitch error, which means it is the summation of the all the pitch errors of individual threads. Let's see what will happens when due to this pitch error. Let assume a bolt has a correct diameters, but its pitch is slightly larger, and nut has the perfect pitch and the perfect shape. Let's see what will happen this bolt and nut having the assembly. Due to this pitch error, threads do not match perfectly with the nut. This contact, it will be shifted to the upper flanks. So due to this pitch error, this contact is shifted to the upper flank. Due to this one, bolt has to be pushed towards the outerwards. Then it will be result in the increase in diameter. Similarly, in the nut point of view, it has to be pushed inwards. It will be result in decrease in diameter. So due to this pitch error, so this contact is shifted to the upper flank. This causes for the interference. Due to this interference, threads must be slightly deformed or maybe the strain it will be takes place. This creates a tight fit or maybe the radial pressure. Due to this radial pressure, so bolts has to be pushed outward and increase in the diameter. Similarly, due to this radial pressure, nut has to be pushed inward, then its diameter has to be decreased. So what will happens due to the pitch error means, for a bolt point of view, its a virtual effective diameter is increases. For a nut point of view, its virtual effective diameter is decreases. Let the total error in pitch of bolt thread over a specified length capital L is small e as shown in the figure. So in the figure, capital L is the total length of the bolt thread and small e represent the total error of the pitch. And we know that when due to this pitch error, interference it will be occur when the assembly of the bolt and nut. And this interference has to be accommodated by the developed strain if the bolt and nut are to be fit together. When there is a pitch error, a side force acts on the nut. This force helps to the bolt and nut fit together even though they are not perfectly matched. So due to this pitch error, perfectly bolt and nut are not matching, but while the assembling, side force which has to be acts on the nut, this has to be develop the interference in the between the bolt and the nut. Even if the bolt has a correct actual effective diameter, due to pitch error, but its actual effective diameter it will be increases. This is called as the virtual effective diameter. Similarly, nut point of view also, it is having the actual effective diameter, but due to this pitch error, its functional diameter or maybe the virtual effective diameter becomes the smaller than the actual size. Whether the pitch is too large or too small, the effective is the same. So due to the small one, clearance between the threads has to be reduces, but too large mean intervals between the threads has to be increases, so effect is the same only. Even if the pitch error is irregular, the overall effect remains the same. Now we will discuss the effect of pitch error in the change of effective diameter. So let's consider the total pitch error over length capital L. When the bolt and nut are engaged, then this pitch error is equally shared at both ends of the thread engagement, which is represented in the figure. So let's consider here. So this is the small e is the pitch error, total pitch error, and this pitch error is equally shared at the both ends of the thread engagement. So here, so E by 2 in the right hand side, similarly E by 2 in the left hand side also. So we know that one, due to this pitch error, effective diameter has to be increases. Then point A should be matched with the point C if there is the no pitch error. But due to this pitch error, point A should not match with the point C. So to make a point A coincide with the point C, point A must be moved upward by a distance AC, which has to be theoretically. So now have to determine this AC value. So let's consider here right angle triangle ABC. Let's consider. So this is the one right angle triangle ABC. So which is the making angle of the theta. So let's consider here angle theta. So now let's take the tan theta. Then tan theta will become the AB by AC. Then AC equal to the AB into cot theta. So we know that one here AB equal to the this half of the pitch error. Then it will become the E by 2. Then AC will become the E by 2 into cot theta. Then total change in diameter it will become the this shift happens on the both of the sides of the thread. So this shift to be happen. So this due to this strain as well as due to this strain also. Then total shift. Then total change in diameter it will become the 2 into AC. Then change in diameter it will become the 2 into AC. Then AC value is the E by 2 into cot theta. Then change in diameter it will become the E into cot theta. And most of the threads, this cot theta value it will become the, so nearly it is the 2. Then change in effective diameter it will become the 2 into E. So change in effective diameter it will become the 2 times of the this pitch error. Next we will discuss the pitch measurement. An error on pitch will result in partial engagement of the making threads. Secondly, the effect of pitch error on effective diameter is approximately double. Therefore, accuracy of pitch in any form of thread is very important. So in the previously we discussed that one. Pitch error is causes for the interference of the assembly of the bolt and nut, and also this pitch error is increases of the effective diameter and which is approximately double. So we know that one change in effective diameter is the 2E. So it is approximately double of the pitch error. And there is the various methods are there to determine the pitch. So in general we have to use the methods are the pitch measuring machine, tool maker's microscope and the screw pitch gauge. So first we will discuss about the pitch measuring machine. So pitch measuring machine is used to measure the pitch of a screw thread in a simple and accuracy way. So first we have to threaded part is fixed between the centers of the machine. Then a stylus, which is the very small pointed tool, is placed in the indicator. So in the schematic I have to observe that one. So first this thread part has to be fixed between the centers. So let's consider here. So there are the two centers are there. In between the two centers you have to fix this thread part. Then this stylus, which has to be pointed tool, has to be placed in the indicated part. So this is the indicated part. And moreover, stylus is selected so that it touches the side of the thread near the pitch line. So here I have to observe that one. So this stylus is touch the sides of the thread which has to be near the pitch line. So it has to be touch near the pitch line. Then different sizes of stylus are available with the machine. So based on the thread pitch we have to select the suitable stylus. Let's see the basic principle of the pitch measurement by the pitch measuring machine. The pitch is measured by moving stylus from one thread space to the next along the axis of the screw. This movement is measured using a micrometer. So here stylus it has to be moves from one thread space to the next along the axis of the screw thread. And this movement of the stylus has to be measured by using the micrometer. A flexible connection allows the stylus to move smoothly, which has to be up along the one side of the thread and down into the next thread space. To place the stylus correctly between the two thread sides, make sure that the point T is always aligned with its index mark while taking the readings. So here let us observe. Here it is the, so one marking is there. So let's consider this is the marking T. So have to place the stylus in the correct position between the two thread sides. Then you should have to make sure by the this pointer T is always aligned with the index mark. Let's see the procedure. So first is the initial setup. First you have to set the micrometer. Reading should be the 0. Then after that one have to place the stylus in the first thread groove. Then also have to fix the position. So here you have to fix the position, and moreover this T also we should have to align with the marker. Then you have to go for the adjust the stylus. We have to fit the stylus properly between the thread sides. We have to adjust until the pointer T has to be matches the line L. So have to adjust this pointer T has to be match with this one line L. Then take the first reading, slightly rotate the micrometer and align the pointer T with the index mark, and you have to note down the reading, that is the reading 1. Then you have to, after alignment of this stylus, then you have to slightly rotate this micrometer. Then it will be movement, it will be occur in the thread also. Then reading it will become. Then we have to take the reading, that is the reading 1. And next we have to move to the next thread. Then move the stylus to the next groove. Similarly have to take the reading, that is the reading 2. Then pitch will become the pitch equal to the reading 2 minus reading 1. Then similarly it is the repeat the along the screw. So it which has to be continuous for the multiple threads, which has to improve in the accuracy. Then I have to check the accuracy, mean return to first position, take the reading again. If it is the same reading, mean it will give the correct value. There is if any differences, once again I have to repeat the same procedure. So this is the pitch measurement by the pitch measuring machine. Thank you.